Good day, engineers. So ngayon, we will have a three-part episode for the sample problems on the shear strength of soil, and this is still for the course Foundation Engineering. So let's start with our first sample problem. So for our first sample problem, it states that a normally consolidated clay is subjected to a direct shear test. Then, the soil fails at 350 Newton force at the top and a 180 Newton force on its side. The cross-sectional area of the specimen is 42.25 cm squared. So, we have to determine first the angle of internal friction, next the principal stresses, and third the angle of the rupture plane. So, for our givens, we will have P sub n is equal to 350 newtons and P sub s is equal to 180 newtons, and the area of the soil is 42.25 cm squared. By the way, as you can see, dun sa given natin, sabi si P sub n or si 350 newtons is applied at the top. So, this is 350 newtons and this will be 180 newtons. So, sabi, that is a direct shear test. Ibig sabihin, yung in-apply natin sa top, kaya siya P sub n, that is the normal load. And yung in-apply natin sa gilid na 180 newtons, siya yung shear stress. Since we are on the direct shear test. So, next one, we'll have the required. So, una yung angle of internal friction, pangalawa yung principal stresses, and pangatlo yung angle of the rupture plane. So, for our solution, so, ang una nating gagawin is para hanapin yung normal stress. So, for our normal stress, that will be sigma is equal to P sub n over AS. So, ibig sabihin, that will be divided lang yung 350 sa 42.25. So, that will be 350 newtons. So, convert natin si 350 newtons into kilonewton. Kaya siya may 1 over 1,000 dito. That is 1 kilonewton divided by 1,000 newtons. And yung 42.25 cm squared is i-convert natin into meter squared. Kaya meron 100 meter over 100 cm squared dito. So, our resulting normal stress will be 14,000 over 169 kilopascal. Yan ngayon yung normal stress natin na ipa-plot natin on our column failure line. Next one will be our shear stress. Our shear stress will just be equal to the normal or the shear force divided by our cross-sectional area. So substituting the values to our equation, so i-convert din si 180 newtons into kilonewton, and same as yung 42.25 cm squared ginawang meter squared. So the resulting shear stress will be 7,200 over 169 kilopascal. So since nakuha na natin yung stresses natin from our direct shear test, so pwede na natin ngayon siyang i-plot on our coordinate plane. So i-plot natin yung normal stress on the horizontal, which is 14,000 over 169. Tapos yung shear stress natin will be plotted on the vertical plane or on the vertical axis, which is 7,200 over 169. Ngayon, ang point na yon is ito. So, yan ngayon yung location nung mga stresses na nakuha natin from direct shear test. Ngayon, para may drawing si column failure line, sabi dun sa problem, normally consolidated yung soil. So, a normally consolidated soil means the cohesion is equal to 0. So, ibig sabihin, ang ipapang-connect natin dun sa stresses na nakuha natin from the direct shear test will be yung 0, 0 coordinate. So, as you can see, dito sa line na to, nakakonekta siya dun sa 0, 0 coordinate. And yung angle from the horizontal axis papunta dun sa column failure line will be the angle of internal friction. So from this one, we can see na nakaproduce tayo ng triangle. Then this triangle, pwede natin gamitin yung tangent function para mapalabas yung angle of internal friction niya. So getting the tangent of the opposite, which is the shear stress, and the adjacent, which is the normal stress. So we could have tangent of phi is equal to tau divided by the sigma. So from this one, i-substitute natin yung value ng tau at ng sigma. We have 7,200 over 169 kilopascal divided by 14,000 over 169 kilopascal. So as you can see, magiging unitless siya kasi magka-cancel out yung dalawang kilopascals. So, para makuha natin si angle of internal friction, we will get the inverse tangent of the quotient netong values na to. So, that will be phi is equal to the inverse tangent of 7,200 over 169 divided by 14,000 over 169. So, calculating that one, our calculator will give an answer of 27.2161 degrees. Ito ngayon yung angle of internal friction natin. So, since nakakuha na tayo ng angle of internal friction, we could plot this one on a Moore column failure diagram. So, plotting that one on the Moore column failure diagram, ibig sabihin nun, yung stresses na galing ng direct shear test will be the stresses at failure on our Moore column failure diagram. So, as you can see, sila yung stresses at point B. So, the goal now, since meron na tayong angle of internal friction, the goal now is to produce the maximum and the minimum principal stresses. So, para magawa yun is, kakailanganin nating gamitin yung mga triangle dun sa Moore column failure diagram natin. So, as you can see, maghanap tayo ng triangle na pwede nating i-extract para makakuha nung kailangan nating values. So, as you can see, meron tayo ditong triangle BCD. Si triangle BCD, automatically, may given siya na 7,200 over 169, which is the height BD. Kasi siya yung shear stress doon. Then, unknown tayo ng delta sigma over 2 and unknown din tayo nung length ng segment CD or DC. So, meron naman tayong angle of internal friction. So, from this triangle, may mapapalabas tayong value. It's either the delta sigma over 2 or the value of the segment CD. So, extract natin yung triangle na yun. So, automatically, this side of the triangle will be 7,200 over 169. Then, meron tayong angle of internal friction na nakuha kanina. So, ngayon, pwede natin makuha from this one. Unahin natin yung hypotenuse niya, which is the radius of our circle, which is delta sigma over 2. So, from this one, we will be using the cosine function since yung given natin is the adjacent side of the angle. So, getting the cosine function, so cosine of phi is equal to the tau divided by delta sigma over 2. So, since ang unknown sa atin dito will be delta sigma, ang mangyayari is, pwede natin gawin na tau times 2 over delta sigma. So, then, magkakaroon tayo ng 2 tau over delta sigma dito. So, ibig sabihin, itong delta sigma, pwede nating pagpalitin sila ni cosine phi. So, it will result to an equation delta sigma is equal to 2 tau divided by cosine phi. Then, substituting yung mga values natin. So, delta sigma is equal to 2 times yung shear stress natin na 7,200 over 169 divided by cosine ng 27.2161 degrees. Then our calculator will give us the delta sigma or yung deviator stress na 95.815 kilopascals. So since nakakuha na tayo ng delta sigma, so still from the triangle BCD, pwede din natin makuha dyan yung length ng segment or yung value x na to, which is the length of the segment CD or DC. So, pwede natin makuha yun through Pythagorean theorem or the sine function. So, for this sample problem, we will be getting it from the Pythagorean theorem. So, that will be x is equal to square root ng delta sigma over 2 squared minus tau squared. Then, substituting yung values, we have 95.815 over 2 squared minus 7,200 over 169 squared. Then, calculating this equation, dun sa calculators natin, it will give you 21.9104 kilopascals. So, since meron na tayong value ng x, and nakuha na din natin yung delta sigma over 2, going back to our more column failure diagram, pwede na nating kunin yung required sa atin na minimum principal stress and the maximum principal stress. So, ang gagawin lang natin is, since ito yung sigma 3 na hinahanap niya, and meron tayong value ng delta sigma over 2. So, ibig sabihin, meron na tayong pwedeng makuha na values ng minimum principal stress. Ang gagawin lang natin is, meron tayong sigma dito, i-add lang natin yung length ng DC, which is yung x. Then, galing dito, so, nandun na tayo sa center ng circle, ibabalik lang natin siya papunta dun sa minimum principal stress by deducting the value of the delta sigma over 2. So, simplify, pupunta muna tayo ng center nung circle natin, which is mapupunta natin through adding sigma f or the normal stress at failure plus yung x value na nakuha natin kanina. So, para dun sa minimum principal stress, meron tayong equation na sigma 3 is equal to sigma c minus delta sigma. Sabi ko nga, pagkagaling mo ng center, kailangan mo na siyang ibalik papunta dun sa minimum principal at point A. So, kailangan mong i-deduct yung delta sigma sa abscissa ng center. So, we will have, sinubstitute lang natin itong equation na to, papunta dito. So, we could have sigma f plus x minus delta sigma over 2. Then, substituting values, so 14,000 divided by 169 plus 21.9104 minus 95.815 over 2, your calculator will give you 56.8431 kilopascal. So that will be our minimum principal stress. Now, for our maximum principal stress, we will have our sigma 1 is equal to sigma 3 plus delta sigma. So, ibig sabihin, galing ka ng sigma 3 since nakuha na natin siya from our previous solution. So, idadagdag mo lang si delta sigma para makarating ka dito, which is ito, si delta sigma. So, pwede rin na kung galing ka na ng center kanina, kasi meron naman tayong equation for the abscissa of the center. So, kung galing kang center, which is ito, idadagdag mo na lang yung delta sigma over 2 para mapalabas yung maximum principal stress. So, that will be sigma 1 is equal to 56.8431 plus 95.815. So, your calculator will give you sigma 1 is equal to 152.6581 kilopascal. So that will be the principal stresses na required sa ating kuhanin. So kinuha lang natin siya through the segments na binigay sa atin nung Moore column failure diagram. So para dun sa last na required natin, balik tayo dun sa Moore column failure diagram natin. I-require niya tayo ngayon kunin yung angle of the rupture plane. So ibig sabihin, kailangan ngayon natin na ma-determine yaan through the Moore circle. Ngayon paano? Alam natin na itong angle na to is pinroduce nitong lines na to. Then, as you can see, yung lines na yon is mag-i-intercept ng arc dun sa Moore circle natin, which is itong arc na to. Then, kung titignan din natin, yung arc na yon is in-intercept din nung central angle natin. So, palitan ko lang yung kulay, which is ito. So, pare sila ng in-intercept na arc. So, ibig sabihin, i-follow nila yung rule na kung ang value nito is theta, that means ang value ng central angle will be twice this value of theta. So, that means the central angle will be 2 theta. And coming from that one, pwede nating gamitin si triangle BCD para magpalabas ng isa pang angle dito, which is alpha. And as you can see, this angle alpha at yung 2 theta na naiproduce natin will be supplement or is supplement to each other. So, that means the total angle ni alpha at ni 2 theta is 180 degrees. So, we must first get an angle alpha coming from triangle BCD. So, magagawa natin yun since alam natin na triangle BCD has a sum of interior angles which is 180 degrees and alam natin na si angle D is a 90 degree angle. So, that is coming from an equation which will be 180 is equal to 90 plus phi plus d alpha. So, ang required sa atin si alpha. So, from that equation, we could produce alpha is equal to 180 minus 90 minus phi. Then, we substitute yung phi na nakuha natin kanina. So, which is 27.2161 and calculating 180 minus 90 minus 27.2161, your calculator will give you alpha is equal to 62.7839 degrees. So, since nakuha na natin si angle alpha, we will now proceed yung supplement na sinasabi ko kanina, whereas si alpha plus 2 theta will be 180 degrees. So, we could create an equation which is 2 theta is equal to 180 minus alpha. So, substitute natin yung alpha. So, 180 minus 62.7839. So, we will have a 2 theta, which is 117.2161. Then, dividing both sides by 2, we could get, from our calculators, a value theta, which is 58.6081 degrees. Ito ngayon yung required sa atin na angle of the rupture plane. So, to sum it up, so here are the summaries of our answers. So, for the first one, the angle of internal friction will be 27.2161 degrees. And for the minimum principal stress, we have sigma 3 is 56.8431 kilopascal. And for the maximum principal stress, we have sigma 1 is equal to 152.6581 kilopascal. And for letter C, the angle of rupture plane will be 58.6081. So that will be all for our sample problem number 1. For our next videos, we will be discussing sample problem 2 and 3. So again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.